As a licensed electrical contractor, you have both ethical and legal responsibilities concerning observed code violations. These responsibilities are heightened when the violations pose a risk of fire or other hazards that could endanger life and property. Choosing not to report such violations can lead to severe repercussions. Firstly, there's the potential for a fire or other dangerous incidents to occur. Secondly, you could face legal liability for damages or injuries resulting from an incident. Thirdly, you risk losing your electrical contractor's license. Given the situation, it is recommended that you contact the local electrical inspection department and inform them about the code violations you witnessed, providing specific details about the location and nature of each violation. It is important to meticulously document all communications with the inspection department, including dates, times, and contact information of the inspectors spoken with. If you are concerned about possible retaliation, consider reporting the violations anonymously through a dedicated hotline or a third party. To protect yourself, keep a copy of the relevant electrical code book and any documentation supporting your observations. Reporting code violations is not only the correct course of action, but also a responsible one. This ensures, firstly, the safety of the building and its occupants, secondly, compliance with applicable electrical codes, and thirdly, prevention of potential hazards. While you might not have initially brought up the violations, your ethical and legal duties compel you to report them now. By doing so, you contribute to protecting the public, preventing possible tragedies, and upholding the integrity of your profession. A key area of concern is the practice of overloading electrical boxes, particularly when tapping into existing circuits for new appliances. The National Electrical Code, or NEC, provides specific guidelines on box fill calculations to prevent overheating and potential fire hazards. When dealing with 12/3 wire with a ground, several factors must be considered when calculating the maximum number of conductors allowed in an 18 cubic inch box. Firstly, each current carrying conductor counts as one conductor. Secondly, each equipment grounding conductor counts as one conductor. Thirdly, all cable clamps inside the box count as one conductor. Fourthly, each device, such as a switch or receptacle, counts as two conductors. According to NEC section 314.16, an 18 cubic inch box can accommodate a specific number of conductors based on wire size. For example, if using 12 American wire gauge or AUG wire, the box fill calculation would determine the maximum allowable conductors. The scenario you described involves tapping into an existing 12/3 wire with ground circuit in an 18 cubic inch box to supply a microwave above the range. This setup raises several code compliance concerns. The existing 12/3 wire with ground circuit already serves some existing load. Adding a microwave to the same circuit increases the total load. NEC section 210.23 specifies the permissible loading of branch circuits. For a 20 amp circuit using 12 AWG wire, the total load should not exceed 80% of the branch circuit rating, which is 16 amps. If the existing load in the circuit is already significant, adding the microwave could overload the circuit, leading to overheating and potential fire hazards. The additional conductors required for the microwave connection further overcrowd the 18 cubic inch box. The NEC requires that all conductors within a box be properly sized and not overcrowded. Overcrowding can lead to insulation damage, short circuits, and overheating. NEC section 314.16 provides guidelines for box fill calculations to ensure that boxes are not overloaded. Tapping into an existing circuit for a new appliance like a microwave should be done correctly and safely. This typically involves running a new, dedicated circuit from the electrical panel to the microwave location. A dedicated circuit ensures that the microwave has enough power and does not overload existing circuits. It also allows for proper overcurrent protection with a correctly sized circuit breaker. Before starting any electrical work, it is essential to perform a thorough load calculation to determine the existing load in the circuit and the additional load of the microwave. This calculation helps determine if the existing circuit can handle the additional load or if a new circuit is required. Ensure that all wiring and connections are made according to NEC standards. Use appropriately sized wire connectors and properly ground all equipment to prevent electrical shocks and ensure safety. Informing the inspectors ensures that the electrical work is up to code and safe. The inspector can identify any potential hazards and ensure that they are corrected before the work is completed. Ignoring code violations can result in serious consequences, including fire hazards, electrical shocks, and property damage. As a licensed electrical contractor, you are responsible for ensuring that all electrical work is performed safely and according to code. You should prioritize the safety of the occupants and report any violations to the appropriate authorities. A more detailed explanation of the NEC requirements related to box fill calculations and conductor sizing can be helpful. NEC Section 314.16 outlines the general requirements for calculating box fill. It states that the volume of a box must be sufficient to provide free space for all conductors, devices, and fittings installed in the box. The calculation involves determining the total volume occupied by all components in a box and ensuring that it does not exceed the box's cubic inch capacity. For each conductor that originates outside the box and terminates inside the box, such as the hot, neutral, and ground wires, count one conductor. Each wire passing through the box without termination, such as in a junction box, also counts as one conductor. All equipment grounding conductors count as a single conductor based on the largest equipment grounding conductor entering the box. Cable clamps, such as those used to secure non-metallic sheath cables, count as one conductor unless they are designed to clamp one or more cables. Each device, such as a switch, receptacle, or dimmer, counts as two conductors based on the largest conductor connected to it. This is because devices take up space and generate heat, so they are counted as double the number of conductors. To calculate the total box fill, you need to add up the volume occupied by all conductors, cable clamps, and devices in the box. Use the following values for conductors based on their size. For 14 American wire gauge, or AUG, wire, use 2.0 cubic inches per conductor. For 12 American wire gauge, or AUG, wire, use 2.25 cubic inches per conductor. For 10 American wire gauge, or AUG, wire, use 2.5 cubic inches per conductor. For 8 American wire gauge, or AUG, wire, use 3.0 cubic inches per conductor. For example, let's calculate the box fill for a box containing the following components. 6 12 American wire gauge, or AUG, conductors, 1 cable clamp, and 1 single pole switch. Firstly, calculate the volume occupied by the conductors. 6 conductors times 2.25 cubic inches per conductor equals 13.5 cubic inches. Secondly, add the volume for the cable clamp, which is 1 conductor, so 2.25 cubic inches. Thirdly, add the volume for the single pole switch, which counts as 2 conductors, so 2 times 2.25 cubic inches equals 4.5 cubic inches. The total box fill is 13.5 plus 2.25 plus 4.5, which equals 20.25 cubic inches. In this case, an 18 cubic inch box would be insufficient, and a larger box would be required to comply with the NEC. When dealing with non-metallic boxes, it is important to consider the type of wiring method used. Non-metallic boxes are typically used with non-metallic sheath cables, such as NMB cable. Ensure that the cable clamps are suitable for use with non-metallic cables to prevent damage to the cable insulation. When installing conductors in a box, make sure to leave enough free conductor length for making connections and future maintenance. The NEC requires that at least 6 inches of free conductor length be left at each outlet, junction, and switch point. This allows for easy access and prevents strain on the connections. Using wire connectors that are appropriate for the size and type of conductors being connected is crucial. Twist-on wire connectors, such as wire nuts, are commonly used for splicing conductors. Ensure that the wire connectors are properly sized for the number and size of conductors being connected. Overfilling a box can lead to several problems, including firstly, overheating of conductors and devices due to restricted airflow, secondly, damage to conductor insulation due to crowding and abrasion, thirdly, difficulty in making proper connections leading to loose connections and potential arcing, and fourthly, increased risk of electrical shock due to exposed conductors or damaged insulation. Therefore, it is essential to perform accurate box fill calculations and use boxes that are large enough to accommodate all conductors, devices, and fittings. If you encounter situations where existing boxes are too small or overcrowded, it is best to replace them with larger boxes or add extension rings to increase their capacity. Remember that electrical codes and regulations are in place to ensure safety and prevent electrical hazards. As a licensed electrical contractor, it is your responsibility to stay informed about the latest code requirements and follow them diligently. If you are unsure about any aspect of electrical work, consult the NEC or seek guidance from a qualified electrical inspector. When dealing with older electrical installations, it is important to be aware of potential hazards, such as outdated wiring methods, deteriorated insulation, and undersized conductors. Older wiring may not be able to handle the increased electrical loads of modern appliances and equipment, which can lead to overloading and overheating. Before making any modifications or additions to older electrical systems, it is recommended to have a qualified electrician inspect the wiring and determine if it needs to be upgraded. In some cases, it may be necessary to replace the entire wiring system to ensure safety and compliance with current codes. When working on electrical circuits, always follow lockout-tagout procedures to prevent accidental energization. To energize the circuit at the main panel and verify that the circuit is energized using a voltage tester before starting any work. Tag the circuit breaker or fuse to indicate that work is in progress and prevent someone from accidentally turning it back on. Use appropriate personal protective equipment, or PPE, such as insulated gloves, safety glasses, and arc flash rated clothing to protect yourself from electrical hazards. Never work on live electrical circuits unless absolutely necessary, and only do so if you are properly trained and equipped. If you encounter any damaged or deteriorated electrical equipment, such as frayed wires, cracked receptacles, or broken switches, replace them immediately. Damaged equipment can pose a serious electrical shock or fire hazard. When installing new electrical equipment, follow the manufacturer's instructions carefully and ensure that it is properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to prevent electrical shocks and minimize the risk of fire. Periodically inspect electrical panels, outlets, and switches for signs of overheating, such as discoloration, melting, or burning smells. Overheating can indicate loose connections, overloaded circuits, or other problems that need to be addressed. If you notice any signs of overheating, turn off the circuit and have it inspected by a qualified electrician. In the specific scenario you described, using the existing 12/3 wire with ground in an 18 cubic inch box to supply a microwave is likely a code violation due to overloading and overcrowding. The NEC requires that electrical circuits be properly sized and protected to prevent overheating and fire hazards. Adding a microwave to an existing circuit can easily exceed the circuit's capacity and create a dangerous situation. The best course of action is to run a new, dedicated circuit from the electrical panel to the microwave location. This ensures that the microwave has enough power and does not overload existing circuits. It also allows for proper overcurrent protection with a correctly sized circuit breaker. A dedicated circuit typically consists of a 12 American wire gauge, or AUG, wire with a 20 amp circuit breaker. This provides enough capacity for more standard microwaves and ensures that the circuit is properly protected. When running a new circuit, use appropriate wiring methods, such as non-metallic sheet cable or conduit, and follow all applicable NEC requirements. Ensure that the wiring is properly supported and protected from physical damage. Install a new receptacle at the microwave location that is specifically designed for microwave use. The receptacle should be grounded and located in a convenient and accessible location. After completing the electrical work, have it inspected by a qualified electrical inspector to ensure that it complies with all applicable codes and regulations. The inspector can identify any potential hazards and ensure that they are corrected before the work is completed. In addition to the technical aspects of electrical work, it is important to consider the ethical and legal responsibilities of electrical contractors. As a licensed electrical contractor, you have a duty to protect the public and ensure that all electrical work is performed safely and according to code. This includes reporting any code violations that you observe, even if it means potentially losing a job or upsetting a client. The consequences of not reporting code violations can be severe, including fire hazards, electrical shocks, and property damage. In some cases, failing to report code violations can also result in legal liability and loss of your electrical contractor's license. The ethical and legal obligations of electrical contractors are outlined in various codes of conduct and regulations. These codes typically require contractors to act in a responsible and professional manner, prioritize safety, and comply with all applicable laws and regulations. If you are unsure about your ethical or legal obligations in a particular situation, seek guidance from a qualified attorney or ethics expert. In summary, as a licensed electrical contractor, you have both technical and ethical responsibilities to ensure that all electrical work is performed safely and according to code. This includes performing accurate calculations, using appropriate wiring methods, and reporting any code violations that you observe. By fulfilling these responsibilities, you can help protect the public and prevent electrical hazards. When working with electrical systems, it is crucial to understand the principles of overcurrent protection and grounding. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current, which can cause overheating and fire. Grounding provides a path for fault current to flow back to the source, which helps to prevent electrical shocks and minimize the risk of fire. Circuit breakers are thermal magnetic devices that trip when the current exceeds a certain level. Fuses are overcurrent protection devices that melt and open the circuit when the current exceeds a certain level. The size of the circuit breaker or fuse should be matched to the ampacity of the wiring to protect the wiring from overheating. The ampacity of wiring is determined by its size and insulation type. The NEC provides tables that list the ampacity of different types of wiring. Grounding is the process of connecting electrical equipment and systems to the earth. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip the overcurrent protection device and energize the circuit. Grounding also helps to reduce the voltage on metal parts of electrical equipment, which can prevent electrical shocks. Grounding systems typically consist of a grounding electrode, such as a ground rod or ground plate, and a grounding conductor, which connects the equipment to the grounding electrode. The grounding conductor should be sized according to the NEC and should be securely connected to the equipment and the grounding electrode. When working with electrical panels, it is important to be aware of the potential hazards and follow safety procedures. Electrical panels contain live electrical parts that can cause serious electrical shocks or burns. Before working on an electrical panel, de-energize the panel by turning off the main breaker. Verify that the panel is energized using a voltage tester before starting any work. Wear appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses, to protect yourself from electrical hazards. Keep the work area clean and free of clutter to prevent accidents. When working with electrical panels, it is important to follow the NEC requirements for wiring and connections. All wiring should be properly sized and insulated. All connections should be tight and secure. All equipment should be properly grounded. If you are not comfortable working on electrical panels, hire a qualified electrician to do the work. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. In addition to the technical aspects of electrical work, it is important to have good communication skills. Good communication skills are essential for working with clients, colleagues, and inspectors. When working with clients, it is important to listen carefully to their needs and concerns. Explain the electrical work that needs to be done in a clear and concise manner. Provide accurate estimates and stick to them. Be responsive to their questions and concerns. When working with colleagues, it is important to communicate effectively and work as a team. Share information and ideas. Be respectful of their opinions. Resolve conflicts constructively. When working with inspectors, it is important to be knowledgeable and professional. Know the NEC requirements. Be prepared to answer their questions. Correct any deficiencies promptly. Good communication skills can help you build strong relationships with clients, colleagues, and inspectors. Strong relationships can lead to more business and a more successful career. The NEC is a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect changes in technology and industry best practices. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is essential for electrical contractors to stay up to date on the latest NEC requirements to ensure that their work is safe and compliant. The NEC is available for purchase from the National Fire Protection Association, or NFPA. It is also available online through various subscription services. In addition to the NEC, there are other codes and regulations that may apply to electrical work, such as local building codes and state electrical codes. It is important to be aware of all applicable codes and regulations before starting any electrical work. Compliance with electrical codes and regulations is essential for ensuring safety and preventing electrical hazards. Failure to comply with these codes can result in fines, penalties, and legal liability. In conclusion, electrical work is a complex and challenging profession that requires a combination of technical skills, ethical responsibility, and good communication skills. By mastering these skills and adhering to the highest standards of safety and professionalism, you can build a successful and rewarding career in the electrical industry.